Welcome to homework.
In this problem, we are again given a beam that is straight, and it has a pin joint at this end and a roller at this end, although there's no horizontal load, so we really don't care about the reaction from the pin in the horizontal direction here. There is a uniform, linearly varying distributed load over the entire beam that maxes out at 6 kilonewtons per meter over here and goes to 0 on this end. And we're asked to find the internal stresses, the internal reactions at the center of the beam. So if you write the equation for this varying load is just 6 minus x in kilonewtons. Now we can make an equivalent point load that would act one third of the way in of the entire length in from this end. So if we sum forces, we get F1 plus F3 minus F2 is 0. And then this equivalent point load acts at a distance of 2 from this end. And so we have a moment from it, and then another moment from this reaction force here. That gives us two equations and two unknowns. And we get that F1 is 12 kilonewtons, and F2 is 6 kilonewtons. Now we make a cut here, and I took a look at this section here just because that means that this was just a triangle. Over here we'd have to do a little more work to get our equivalent forces. So if we just look at the right hand side, we still have another triangle here. And we can again find an equivalent point load and an equivalent moment for that distributed load. So if we sum forces now, we have minus V1 minus F2 prime, which is just the area under this half of the distributed load, plus F3 equals 0. And then if we sum moments about this end, this distance here is 2 meters, because this was 3, and we have to go 2/3 the way in from this end, where this would act. And then this is 3 meters, so we have a moment from V1, and then we have the internal bending moment. So again, now we have another two equations and two unknowns. And if we included the longitudinal, the normal force here, that was just going to be 0 because we have no other normal forces, so that is easy to find. But then we take these two equations and solve them. We get that M1 equals 13.5 kilonewton meters and V1 equals 1.5 kilonewtons. So again, it basically makes sense. It's hard to really judge, but you can look up here that it makes a lot of sense that this reaction force is much greater than this because most of the load is on the left-hand side of the beam. So that makes sense. And again, you can kind of check the signs here to make sure they make sense. That the reaction force is actually trying to keep the beam is in a positive in this direction. So it's actually trying to keep the beam bend the beam back up, reacting to these forces trying to bend it down.